actually have it read somewhere. Okay.
This is problem 4. And the question is very straightforward. What percent of the molecules have kinetic energy, E sub k, greater than or equal to K sub B times T? So this is a simple percentage problem. We simply have to cast get the information in some sort of decimal fraction and then convert that to a percentage. Now, it turns out that this is also a Boltzmann's law problem, and Boltzmann's law reveals this. It turns out within Boltzmann's law, this fraction is given by e to the minus e sub k over k sub b times t. And so this is a great simplification. All we have to do is solve this. This is the type of problem we're going to be encountering over the course of the course. And understanding this is going to make life a lot clearer. It boils down to knowing when to add and when to multiply. And the exercise you want to go and practice with in order to solve problems like this is contained in the characteristic and mantissa handout. And so these are the skills we're going to be developing. But it always comes down to knowing when to add and when to multiply. You either add or subtract or multiply and divide. And so first we'll start out by substituting in this expression equals e to the minus kbt over kbt, k sub bt. And that's easy enough to solve. This turns out to be e to the minus 1. Again, very straightforward. Now, we're going to use the rules with exponents and substitute in, and we already know this from that exercise to the characteristic of the mantissa, that e is equal to 10 to the 0.434. And this is raised to the minus 1. And now we have the rules of exponents coming into play. The rules require, in this case, when I have an exponent, a number that's an exponential number, and it's raised to a power, well then I multiply. So I'm going to have to multiply. In this case, the multiplication is a trivial one. This is equal to 10 to the minus 0.434. And the reason we can do this is because we know that e is equal to 10 to the 0.434. This we know from our work with the characteristic and the mantissa. Now we've got our number in 10 raised to some power, but we have to convert this to a number that is going to be revealing of the decimal fraction. And so, more on the scientific notation, the first thing we have to do is, with the scratch paper now, I'm going to go 1.000 minus 1 plus 0.434. And that's going to be a 6. This is going to be a 6. And this is going to be 5. So, having done this, I now can write this in this form. The 0.566 times 10 to the minus 1, which is the form we needed. This is going to be the standard scientific notation format. It's going to be a number with 3 sig figs multiplied times a characteristic term, 10 to the minus 1. And now we're going to have to dust off the scratch paper and practice a few of the things we learned, the skills we learned in the characteristic and the mantissa term. Because of the following, I know that 10 to the 0.566 is somewhere between because 10 to the 0.477 is equal to 3, and 10 to the 0.602 is equal to 4. So I know my answer here has to be somewhere between 3 and 4. So we need to work on scratch paper to find out what it is so we can finish our problem. And it turns out my first guess is going to be 3.5. Okay? And 3.5 is equal to 7 times 5 times 10 to the minus 1. And so the log of 3.5 is going to be that. So then the log of 3.5 is equal to the log of 7 plus the log of 5 plus the log of 10 to the minus 1. And that turns out to be 0.845 plus 0.699 minus 1. And that, I've got to do my little scratch paper again, 0.845, 0.699, 9 and 5 is 14, 9 and 5 is 14, 6 and 9 is 1.544. So this is equal to, so the log of 3.5 is equal to 0.544. Well, that's below this. So I know it's a little bigger than 3.5. Let's go back and try again. I've got 3.5 down, so now I'm going to factor it to 3.6. And 3.6 is equal to 6 squared times 10 to the minus 1. So, therefore, log of 3.6 is going to be equal to the log of 6 squared plus the log of 10 to the minus 1. And that is equal to, what do the rules with exponents have me do here? I pull this 2 through. This is equal to 2 times the log of 6, and this is minus 1, and that's equal to 2 times the log of 6, which is 2 times 0.778 minus 1. So 0.778 times 2, 16, 7 times 2 is 14, 15, 7 times 2 is 14, 15, 1.556. So that means this is equal to 0.556. Awfully close. Much closer to the actual number. So we'll call this a day and substitute that in. So this gives us our answer. All this was scratch paper. True, a lot of scratch paper, but we were practicing some skills that you're going to have down when the test comes around. It comes with practice. And so I can erase this. And I'm going to leave this up for just a second. This turns out to be equal to 3.6 times 10 to the minus 1, which is equal to 0.36, and therefore 36%. We've now answered the question. I can erase my scratch paper. This is what you would put on the board. Now, I want to call your attention to the following point. I had to get it in this form, which is the standard scientific notation form, so that I could rewrite it in decimal form and use this decimal fraction, which is because the definition of percent is parts per hundred. So 0.36 is going to be multiplied times 100 is going to be 36%. Okay, and that is answering the question. But this was more of a practice of some of the skills we're trying to develop.